Okay, we're going to start Chapter 3. It's entitled Inverse Functions. We'll start with 3.1, Exponential Functions. So just a few notes here. First thing, we're going to go through this real quickly. This was studied in college algebra, so I do expect that you would understand the basic concept of an exponential function. If you need to, go back and review. But here is general idea. All exponential functions have the form f of x equals a to the x, where a is a number that's bigger than 0 and not equal to 1. A is called the base, and then the exponent is the variable x. So what we're looking at here is the graph of a to the x whenever our a is bigger than 1. So if the base of this is a number larger than 1, then your graph will increase all the time. As x approaches infinity, the limit goes to infinity also. So as you go out to the right, the graph goes up to infinity forever. As x approaches negative infinity, you go and you have a horizontal asymptote at 0. So your function approaches 0 as you approach negative infinity. Also, remember that if you plug 0 in for x, you get a to the 0, which is 1 for any base a. So that's the basic idea of a to the x, where a is greater than 1. If a is less than 1, but still bigger than 0, then your graph basically flips over. And what you get is, as you take the limit as x goes to negative infinity, your function approaches positive infinity. That's this. And as x approaches infinity, your function goes asymptotically towards 0. So your function approaches 0. So that's the basic graphs of a to the x. We've seen that before. Now, a couple of things about the properties of exponents you need to remember. First, if a is greater than 0 and a is not 1, then an exponential function a to the x is continuous on the entire real number line. So you can see from our graphs that these pictures are nice, or these curves are nice and continuous. They don't have any jumps in them, no breaks, no gaps. So they're continuous everywhere. Also, some properties of exponents. If you have a base here, being raised to the x plus y, that's the same as a to the x times a to the y. If you do subtraction in the exponent, then it's division over here. If you take something and raise it to a power, and then you raise that entire thing to another power, that's the same as just raising the base to the 2 powers here multiplied. And then if you have 2 bases being multiplied raised to the x, then you can just apply the x to each of the bases. So you get a to the x and b to the x. That's all the properties we're going to need to know, or the basic properties that we'll need to know for exponential functions.